almost like a sandbox environment where you have many projects going on, and Synbio is organized in a way that those projects can come together, those researchers can come together and talk about common problems or common challenges in a way that helps them all achieve their broader goals and helps the synthetic biology community achieve its goals of making biology by design de rigueur. So I would say it's democratic. I would say that it's very much based on the sort of it's top down in the sense that much of the fundamental research is based on or driven by specific applications, such as a tumor-seeking bacterium or chemically manufacturing a biofuel within a bug. So the fundamental challenges that are required to do those things are what really kind of feeds Synbio, at least at the Berkeley level, I would say. That might be a complementary approach to how you would approach synthetic biology or how researchers approach Synbio on another level. So that commonly there's this sort of, I think it's a false dilemma about whether you make synthetic biology top-down, meaning you start with a project and build down to the fundamental level, as I just described at Berkeley, or whether you build parts from the bottom up and you assemble the parts into devices, and then the devices in turn get assembled into applications. So there's kind of a false dilemma that that you kind of have to pick one way or another, or that one way is better than the other. And I think that the approach that we've taken here at Berkeley of just having an open environment that allows people to pursue their projects while also encouraging them to explore the fundamental common challenges of synthetic biology is probably the happy middle ground. I can tell you a little bit more about how the projects are selected. Maybe I didn't really answer that part of the question. So the way that we sort of choose which projects Synbio is working on is there's an annual process by which the researchers basically put their projects into a database, a web-based database. And all of the researchers get to review those projects in a very democratic way, and anybody who has any feedback is welcome to provide that. Essentially, funding for Synbio is pretty constant for each of the PIs, and so it allows them to fund about 2 researchers per lab, is what it turns out to be, and kind of plus and minus here and there. The review process is really very open and permissive, and again, there's a sense that it's not about telling people what they can or can't do. Certainly, there may be some encouragement one way or the other, but it's more or less to try to draw connections among and between projects, and to try to build collaborative efforts. I think that really gets to the heart of our challenge in terms of catalyzing biology as an engineering discipline, which is to find out where we have these common problems and to see if we can't engage one another on collaborative efforts to overcome them.
I don't know if you wanted to talk about this on camera or not, but about peer review at all?
Oh, sure. Yeah, sure. So just So Prairie View A&M University is located about an hour, I think, northwest of Houston. And Prairie View was originally selected as an outreach institution. It's an historically black college, and the NSF takes very seriously, as does Synbio, the effort to sort of reach out to traditionally underserved communities. We've had a very happy relationship with Prairie View over the course of the 2 years that the project's been going on. I believe at the encouragement of NSF, we decided early on, rather than have them be an outreach institution, we would make them a full research institution along with MIT and Harvard and UCSF. I think that was probably a very good idea. I think it's been challenging in the sense that Prairie View doesn't have a very big graduate program at their university, and so they don't have some of the same research culture that universities such as UC Berkeley or the others have. And so in our going into our third year now, I think we're re-examining how to really instill that research atmosphere within Prairie View. And I don't think that it was quite as straightforward as we originally anticipated, but I think there's still a lot of opportunities for us to sort of seize upon.
Okay, so now we're gonna try these questions.
The big ones?
The big ones. Okay.
Okay.
Here we go. So, how would you describe flourishing?
So the way that I would describe flourishing is when people are engaged in meaningful work, not just to them but to others around them. So I think that when meaningful work is going on, not only is there a sense of optimism that prevails, but also people just don't, they have good products. And so, when a lot of times, when things when people feel like they're working on meaningless projects, then I think or projects that maybe are very, very focused and don't have a sort of big benefit. Like, at Synbio, we always say that we're trying to, catalyze biology as an engineering discipline. It's an ambitious goal, but even for somebody like me who's not a scientist, it's something that sort of wakes me up in the morning and reminds me that, hey, I get to go out and, I'm going to change the world a little bit, even if it means I'm pushing papers or calling people on the phone and, doing budgets, whatever it might be, I'm playing a role in this bigger effort to really make something important happen. So I think that when that kind of work is going on, and when an administrator can get up in the morning and feel good about what he or she is doing, then something good is going on, and I would call that flourishing.
Okay, now
Ooh, it's a corny answer.
no, it's flourishing is a corny question, honestly.
Yeah.
But I am curious. I'm going to take this further. So, what do you mean by meaningful?
So, by meaningful, I would mean that it has benefits that go beyond the immediate lab. So, there are. I'm here at Stanley Hall, and there are many researchers from a number of different disciplines, and they're all working on really good stuff. Some of them are working on specific, the physical properties of MRI scans and how do you improve them to get better resolution. I think it's great. It has these people are working in very specific areas to, internally